Hey everybody, Alex from SCADA Forge here. In this video we're going to cover Automation 101. If you're familiar with the manufacturing industry and automation in general, you can probably skip over this. This is meant to set up some understanding of automation, some of the terminology that we're using, talk about some of the equipment, and compare what you might see in a manufacturing facility, in this case to a car, so we can start to understand how things you might see in a manufacturing facility like pumps and valves and instruments map to something in the real world most people are familiar with a car. So let's dive into it. And we'll share links to any resources I show here in the video as well. So first, what is SCADA? You might see this pop up in the manufacturing world quite often. SCADA simply stands for Supervisory Control and Data Acquisition. And this refers to the technology platform that effectively allows manufacturing companies to operate their facility. It will provide the user interface that operators will use to run process equipment, manage alarms, change set points, get an idea of what the process is doing. It can also integrate with business systems. So maybe we're tying into a customer ordering system, recipes that are stored in a database and pulled across that we can run on the plant floor, and those sorts of things. And it's basically the glue that ties everything together to run a manufacturing process. And the screenshot here comes from the Ignition water treatment demo. This is an example of a screen that you might see at a water treatment facility. We see various pumps. We see tanks with levels, a bunch of different values and indicators throughout the screen. These are all indicating, whether these pumps are running, what our temperature on our raw water is, our turbidity that's coming from a turbidity measurement device, a flow that's coming from a flow measurement device that's reading the flow going through a pipe. The tank levels indicate how full the tank is. There'll be a level sensor, and there's various different kinds of level sensors that are in use depending on what type of material they are measuring the level of and how we need to manage that in a factory setting. That would go well beyond the scope of this video in terms of specifying that, but just be aware there are, sensors to measure levels in tanks, flows, temperatures, pressures. You can measure things like pH, turbidity, pretty much anything you would need to know to understand or control a manufacturing process, we can measure with an instrument. Now, all of these instruments do not connect directly to the SCADA system. Those connect to a device called a programmable logic controller, or PLC, that we'll get into here in a minute. But this is a basic idea of what a SCADA system is it's basically a technology platform that ties all of the pieces required to run a manufacturing facility together. Now, what is Ignition? Ignition is a SCADA system. So it runs on a computer somewhere, in this case called the Ignition server. This can either be a computer sitting at your desk, it can be a computer in the cloud, it can be in a data center in a manufacturing facility. It just needs to run on a computer, and it can run on Windows operating system, Linux, or Mac operating system. So you get a lot of flexibility there. The Ignition server will have clients shown here with the computers and mobile devices and tablets that display similar to this water treatment screen. They'll display what we're looking at, so an operator can interact with the Ignition server, view data that's coming from that, send set points, manage alarms, etc. Ignition can also connect to databases. So if we're storing recipe information, we're tracking historical data from the system, so on and so forth. We can store all of that in a database, and Ignition can read and write to databases very easily. and then make that data available to the operators in the clients. And then we also see here in the upper left, we see PLCs, or programmable logic controllers. These are effectively specialized computers that allow us to connect to equipment in the field or out on the factory floor. And Ignition can send data and read and write data to the PLCs. So we can send over set points. We can read data from instruments, pumps and valves, etc. The PLC then has what's called logic within it for programmable logic controller. And the logic that you program tells the PLC how to operate the plant. So that might be, let's say our tank 1 is getting low and we want to fill it. The logic in the PLC would read the tank level, and if it gets below a certain value, say 50%, it may open a valve or start a pump that fills that tank up. And then when it gets to a certain set point, say 75%, it will tell that valve to close or that pump to shut off to stop filling the tank to prevent it from overfilling. We could also say, let's say we want to get a certain flow through our raw water pipe. Maybe we want to get 12 gallons per minute instead of 11.7 here. The PLC would then tell these pumps either to speed up or to start an additional pump to meet that flow rate, and then it would control the speed of those pumps to maintain whatever our set point is there. And that's all done in the logic in the PLCs, which kind of goes beyond the scope of what we're talking about in these videos, since we're focused on Ignition. But be aware that a programmable logic controller, or PLC, is effectively the brains that operate the plant. You can operate a facility without a SCADA system. So a PLC could exist on its own, and maybe there's, some push buttons and things that an operator can use to start and stop equipment. But tying a PLC in with a SCADA system gives you a lot of flexibility to be more intelligent about how you're running your process, collect historical data over time, and basically get a good picture of how your facility is running and allow your operators to control that. And then you can also, through the Ignition server, let's say we're pulling up a recipe, we can pull data out of a database, parse that out into Ignition to tell the PLC what it needs to run its operations. So this is an example of a Groove Epic PLC here on the right from a company called Opto22. There's many different brands of PLCs that have different price points and different capabilities. We like Opto22 at Corso, so we're featuring them here. And this comes from our P&ID Drawings 101 blog post. This is a good introduction to what you might see on a factory floor, if you want to check that out. Effectively, we have the PLC that is then through these I/O modules that have the blue lights on them here. These allow us to wire out to the devices. So this can be wired to a transmitter. So we're getting a signal from this transmitter sent back to the PLC, and the PLC can understand what that signal means. And let's say we need to scale that from, say, 0 to 100 gallons per minute into some value that we're displaying on the screen. We're typically going to use something like 4 to 20 milliamps as an industry standard. So this will send us a current over the wires to the PLC. The PLC will interpret that electrical signal, and then we can scale that in the logic to be from 0. So 4 milliamps would be 0 gallons per minute, and 20 milliamps would be 100. And then we can display that on the screen. We'll also see that this is broken down. We have a sensor on the bottom. That's what actually does the measuring. So if you have any type of instrument, that's what this entire device is called. You'll have some form of sensor. In this case, it's a flow meter. So we would connect a pipe to each end of the bottom section here. And inside this housing is something that measures the flow rate of a liquid through or a gas through that pipe. And then through this stem here that is wired up to the transmitter. And inside the transmitter, there's a little operator interface with some buttons they can use to navigate. And that handles the electrical signal coming from the sensor and converts that into something the PLC can then use to know what's going on with the system. So that's, fairly complex if you're just looking at this for the first time. But effectively, you would specify, what type of, in this case, what type of flow am I measuring? Is it water? Is it a gas? Is it like oil or gasoline or something? That would determine what type of sensor type we need. Then we would specify various ranges and things for, say, it needs to read from 0 to 10,000 gallons per minute or 0 to 100. And we would get a transmitter that meets our specification requirements, get everything ordered. Then various mechanical and electrical contractors would install everything in the facility. And then system integrators like us would come in, write the PLC logic, build the SCADA system, and tie everything together. Now that is fairly complicated, looking at it for the first time. So let's go to a simpler analogy that may make sense for the real world. So if you think about it, a factory is very similar to a car. In the car's case, our product is getting us from point A to point B. We do that by using the engine to move the car. And there are various sensors and actuators and things in the car. These would be akin to the instruments, like we have, temperature readings, fuel gauges, speedometer and odometer readings and things that give us information about how the car is functioning. And then there's various actuators. So these would be like your fuel pump, your valves that get fuel into the engine cylinders and things that are also controlled and part of the overall control system of the car. So we have the engine. That would be basically the same thing as a motor in a facility. So if you were thinking about, say we're running a conveyor system and we want to set a speed of a conveyor system, that's effectively the same thing that we're doing with a car. We're telling the engine with the gas pedal and the brake pedal, hey, we need to speed the car up. Let's give it more gas and the car will go faster. And then if you let off the gas, the car will start to slow down because the engine is not going as quickly. That's no different than a PLC controlling the speed of a motor to maintain conveyor speed or a pump to maintain a flow rate through a pipe. And this is all controlled through the engine control module. That would be akin to the PLC. So this takes all of the signals from these various sensors and actuators. So let's say the gas pedal is tied into the engine control module. The engine control module then sends commands to the engine to tell it to speed up or slow down and manage the speed of the car. And then we also have, in the factory or manufacturing world, the idea of automated control. So let's say the operator wants to set a set point of 12 gallons per minute, and the PLC manages all of the process variables to control the speed of pumps. That would be very similar to cruise control. So in a car, we're setting, say I want to go 70 miles an hour as my set point. The engine control module will tell the engine and the various sensors and actuators what they need to do to maintain that. Then if we start going up a hill, the engine control module is going to tell the engine to speed up to maintain that speed. If we're going downhill, it's going to tell it to slow down because we don't need more power to go downhill. We can use gravity. And that will allow us to effectively have automated control of the car. And as you get into more advanced sensors, like determining if there's a car within a few car lengths ahead of you and it needs to slow down and have adaptive cruise control, we can also program things like that into PLC logic and really have a lot of power over how the process is running. So a car is effectively a very simplified version of a manufacturing processing system with an engine control module acting as a PLC, all of the sensors and actuators that you might see on the plant floor operating the equipment in the car, and then the engine acting as a motor to do what we're trying to do. If it's a manufacturing process, we're doing processing on raw materials to make goods. In a car, we're simply trying to get the car to drive to where we want it to go. And then that would also, the engine control module is dealing with steering. That'll get the car to turn left or right. It's determining if you're in drive or reverse, or if you're in park, then you're not driving anywhere. So the engine control module is not controlling the speed of the car because you're parked. If you're in reverse, it would tell the engine to go in the opposite direction, or handle the transmission to shift the gears to do that. In a conveyor system in a factory, it would be like forward motion goes one direction. If we reverse the motor, it goes the other. And then the one limitation to a SCADA system is we're not really getting like historical data collection on the car. We'll get some data points we can look at here in a second, but you're not necessarily going to see a trend of your like engine temperature over time, for example, in the car. So to think about a car in terms of a SCADA system, we're effectively looking at the dashboard. We have, our engine RPMs, our engine temperature on the left, what mode of operation we're in this case, park. We could be in reverse, neutral, drive, low gear. We have an overall range. This is a calculation that's done based on how much fuel we have remaining, tracking of our average miles per gallon for this trip, maybe an outdoor temperature, an overall odometer for how far the car has traveled over its life. Then the speedometer, this would be similar to an instrument, that this is going to take in data from our wheels and how fast they're turning, and the diameter of the wheels and things to calculate a speed of the car. And if we were to, say, change our tire size, we may need to have that recalibrated in the engine control module. And then we'll have a fuel gauge, and a SCADA system will also give you alarms. So if we were to, say, have a high tank level on that tank 1 example, we can get an alarm that alerts the operator, hey, this tank has a high level, you need to go look at it before it overfills. That would be similar to like a low fuel light or a check engine light, where you're getting an alarm signal from your car or your fuel gauge that says, hey, you need to fill up the tank, or you need to go to a mechanic and have them do some diagnostics to check your engine. We also have things like blinkers and windshield wiper controls on the steering column. And then again, we would have our gas and brake pedal down below that are also inputs to the system to tell the engine control module what you're trying to do with the car. So that would be effectively the same thing as a SCADA system. Instead of running a manufacturing process, we're running a car. I think that's about as simple as I can make the concepts. I think the car to factory analogy is a pretty apt one. If there's any questions remaining on this, please reach out and let me know, and I can update the video to answer them. I think that kind of ties all of the big puzzle pieces of the manufacturing world together. If you want to look at the demo where I pulled that screenshot, you can go to demo.inductiveautomation.com, and they have a number of different demos here describing different processes and features of Ignition. We have our P&ID Drawings 101 blog post. This is a series that, this is an example of what you might see to describe what is in a factory. This is a particular piece of a process that gives us instrumentation information, in this case a tank that's getting heated, where we have a level sensor and so on. This blog post is designed to take you through all of that and describe from a little bit higher level, more in-depth view of looking at P&ID drawings, comparing them to a factory. And I also really recommend how it's made to get some real-world experience with what the equipment looks like in a factory. You may even see some SCADA screens there. I really like the cocoa beans and bulk chocolate episode. That was one of our early clients at Corso Systems who made this. And this is about their entire process. We have used Ignition and PLCs at their facility to automate a lot of their equipment. You can also, if you're near a factory, you can probably take factory tours. I know a lot of like breweries and candy companies offer tours. That would also be a good way to get some visibility into what a plant floor looks like. And you can start seeing valves and motors and control panels and all the things that make factories operate in the real world. So thank you for watching, and please reach out if you have any questions. I'm doing my best to make this as comprehensive and easy to understand as possible. So I appreciate any feedback. Thank you for watching, and have a great day.